Okay, so in class we talked about solving basic log equations. Here what we're going to do is we're going to apply some of our log rules in order to solve a little bit more complex equations. Okay, so we have 3 log rules. We have the product rule, we have the quotient rule, and we have the power rule. Now product we know means to multiply. If we have log of 2 terms that are being multiplied together, we can actually expand this out into 2 separate log terms by putting an addition sign in between them. So if we have log base b of a times b, we can separate this into log base b of a plus log base b of b. Okay? You see an example over here. If you have log of 4x, you could rewrite that as log 4 plus log x. And if you want to, try it out in your calculator to see why this works, instead of doing an x, let's plug in a number. Let's plug in log of 4 times 2 in our calculator. And let's see if that's equal to log of 4 plus log of 2. Okay, so I'm going to do this. I'm plugging right now in my calculator log of 4 times 2. Basically log of 8, right? So if I plug log of 8 in my calculator, it gives me an irrational number that keeps going, but it's approximately 0.9. Now, if I plug in my calculator log of 4, and then close the parentheses, plus log of 2, guess what? That also gives me approximately 0.9. It gives me the same exact answer. All right, so anyway, our next rule is called the quotient rule. Quotient we know means to divide. So if you have log of a divided by b, we can split that up into 2 separate log expressions by putting a subtraction sign in between them. So we could do log of the numerator minus log of the denominator. So this would be log of a minus log of b. Okay, so an example over here shows log base 2 of 3 divided by x is equal to log base 2 of the numerator, so log base 2 of 3, and then minus log base 2 of x. Okay, log base 2 of x. So what you have to remember is that multiplication splits up into addition, and division splits up into subtraction. Okay, so division goes with subtraction, multiplication goes with addition. And then the third rule is called the power rule. The power rule just says if you have an exponent, you can take that exponent and bring it to the front of the word log. So we can rewrite log base b of a to the c power as, okay, take that c and bring it to the front, c log base b of a. So if we look at the example over here, it shows log of x squared. If you take that exponent and bring it to the front, can be rewritten as 2 log x. Okay, so now let's apply these rules to some of the equations below. Okay, so let's take a look at number 1. Now, in number 1, you see here we have log plus log. Okay, so we have 2 logarithmic terms being added together. Now, the first thing we want to do is we want to try to take these and we want to combine them so that they make one single log expression. Now, I put the product rule over here to the side. I know you have it on top of your paper. And we're going to actually kind of work from right to left. See here how if we have log base b of a plus log base b of b, if we want to make that into one single log expression, we can do that as long as we take the a and the b and multiply them together. Okay, so if we have log base 4 of x minus 7 plus log base 4 of x plus 5, we can make this into one single, I'm going to do this right here, into one single log expression on the left-hand side of the equation, as long as we take, see how we have the a and the b being multiplied together? So as long as we take the x minus 7 and the x plus 5 and multiply them together. So I'm going to write x minus 7 times x plus 5. And then I'm just going to bring down the right-hand side of the equation. Now, if you want to multiply these out now, you can, or you could wait till later. I'm going to actually wait till later. But now, this is pretty much like we've seen before. We have one single log term on, the left-hand side of the equation, and we know in order to solve this, right, we can now circle the base and run the race. So let's do that, okay? I'm going to circle the base and run the race. So what that means is this 4 is now becoming the base on the other side of the equation. So we're going to have on the other side of the equation base 4 to the 3rd power And since I've moved this base, the word log drops off, and I'm just going to bring down the x minus 7 times x plus 5. Okay, and this is the equation we're going to solve. So to solve this, we would just double distribute, right? So that would give us x squared plus 5x minus 7x minus 35. And then 4 to the third is just 64. Okay, so now we know in order to solve this equation, right, since there's an x squared, we want to get this side of the equation set equal to 0. So I'm going to subtract 64 from both sides of the equation, and I'm going to combine my like terms on the left-hand side of the equation. All right, so this gives me x squared, and then 5x minus 7x combines to give me negative 2x, and then negative 35 minus 64 combines to give me negative 99. So now all we have to do is just factor and t-chart. So if I factor this, since I have an x squared, I'm going to put an x and an x. And then this is just am, two numbers that add to negative 2 and multiply to negative 9. So that'll be negative 11 and positive 9. All right, and then I'll make the t-chart and solve. So here I get x equals 11 and x equals negative 9. Now it's really important to take your values that you get and plug them back into the original equation and make sure that it doesn't create a 0 or a negative log, because remember, logs always have to be positive. Actually, you know what? Let's write that down. That's really important, okay? Logs must be positive. So what we're going to do is we're going to check for any values. I mean, we don't just cross off a value. We don't just say, oh, look, this is negative 9. Let's cross it off. We only cross it off if, when we substitute it back into the problem, it creates a negative. So you have to check your positive values as well. So if I take positive 11 and substitute it back in, 11 minus 7 is positive 4. So that's positive. That's good. And then 11 plus 5 is positive 16. So that checks. So we can circle this. This answer is good. All right, now if I plug in negative 9, what we'll see is negative 9 minus 7 is negative 16. We've created a negative. So if it creates a negative anywhere, you write it right away, cross it off, okay? We cannot create negative or 0 logs. I'm just going to write that for this example. Cannot have negative or 0 logs. Okay, but just to kind of firm up, even if we took the negative 9 and plugged it in here, negative 9 plus 5 is also a negative. So, I mean, it creates negatives here and here. But the rule is if it creates a negative anywhere, then we can't use it. Okay, so in this video, we're going to do the odds together, and then tomorrow night's video, you guys are going to do the evens. Okay, so if we take a look at number 3 then. Now, this one, we see that we again have addition, right? So I put the product rule here, right? Does an addition match up with multiplication? But also what you'll notice is there's a number in front of our log. And when that happens, we're going to have to use that third rule, the power rule right here. Because doesn't the power rule say that you can, if you have an exponent, you can take it and bring it in front of the word log? But just like, you know, we did with the addition rule, right? We're working from right to left when solving an equation. We're going to do the same thing here. We're going to work from right to left. You can take what's in front of the word log and move it so it becomes an exponent, and then you'll be left with what we have on the left-hand side of the equation. So what I mean is, and you always apply the power rule first, and then you apply either your product or quotient rule. So see how we have a 2 right here in front of the word log? I can take that and make it an exponent on the x. So I can first rewrite this as, let me just get my pen here, as log, okay, I'm going to move this up here. So log of x squared plus log 4 equals 2. Okay, so the power rule tells you can take a number in front of the word log and make it an exponent. All right, so now I'm going to apply my quotient rule, right? The quotient rule says, I'm sorry, not quotient rule, the product rule. The product rule says if you have two logarithmic terms that are being added together, we can make them into one single log term by multiplying them. By multiplying, what comes after the word log. So I'm going to rewrite this as log of, now instead of writing x squared times 4, wouldn't we normally arrange that as 4x squared, right? X squared times 4 is 4x squared, so we have log of, I'm going to just put that in a parenthesis, 4x squared, and I'll bring down the equals 2. Now from here, once we have it so we have one single log on the left-hand side of the equation, or the right-hand side of the equation, wherever it is, we circle the base and run the race. But the problem is, I don't see a base here. All right, whenever you don't see a base, what they're telling you is there is a base of 10. Okay, so it's assumed that there's a base of 10. So let's take the 10. I'm going to actually put that in right from the beginning of the problem. If you guys can just insert a 10 as your base into every step. So now this says log base 10 4x squared equals 2. Okay, so now we could circle the base and run the race. So when we circle the base and bring it as the base on the other side of the equation, on the right-hand side of the equation, we'll have base 10 to the second power. And then on the left-hand side, now that the base is no longer here, the word log drops off, and you can just bring down the 4x squared. And this is what we're going to solve. Okay, so so we have 4x squared equals, 10 squared is 100, so let's square that. And then, there's a couple different ways you can go about doing this. At this point in the year, I think the easiest way to do it is just to divide both sides of the equation by 4, leaving you with x squared equals 25. And then, when we take the square root, we know this x squared tells us, right, that we should have 2 answers here, or a maximum of 2 answers, really. So that's going to give us x equals positive and negative 5. Now remember, we said it's important that we take our answers and plug them back in and make sure that we're not creating a negative log or a 0 log anywhere. So let's start with the positive 5. If I take positive 5 and plug it in, well, this is the only spot there is an x, so that would be positive 5, so that's okay. But if I take the negative 5 and substitute it back in, we would have 2 log of negative 5. We can't have a negative log. So here, the negative answer is not going to work for us. So you can, cross off the negative. You know what? I'm going to actually rewrite this. I'm going to just say x equals only positive 5. Okay? Okay, so if you flip to the back, let's take a look at number 5. Now, number 5, I actually put the quotient rule up here because if you see in our problem, we have subtraction. And we know that if we have 2 separate log terms with a subtraction sign in between them, we can make them into one single log term using division, right? You would just take what's to the left of the subtraction bar, and that goes on top of the fraction, and you take what's to the right of the subtraction sign, and that's what goes in the denominator. Okay, so let's do that here. So if we want to make this into one single log term, we're just going to write log base 2 of what's to the left of the subtraction bar, and put that over what's to the right of the subtraction bar. Okay, so let's rewrite this as log base 2 of, so we said the x squared minus 5x goes in the numerator, and then the x plus 9 goes in the denominator. And we can bring down the equals 1. Okay, so what we're trying to do is we're trying to condense these from, 2 terms into 1 term. Because then, once we have one single log term, we're able to circle the base and run the race. And you cannot do that until you have one single log term. Okay, so the 2 becomes the base on the right-hand side of the equation, so that becomes 2 to the first power, which is just 2. And then on the left-hand side, I'm just going to take that fraction, x squared minus 5x over x plus 9, and bring it down. I'm not going to put it in parentheses anymore. If you want to, you can, but we don't need the parentheses. So let's see, since this side of the equation is a fraction, and this side isn't, why don't we just put this over 1, and then we can just cross multiply, right? When we cross multiply, we do the top left times the bottom right. So x squared minus 5x times 1 is just x squared minus 5x. So we'll bring that down. Okay, and then we do the top right times the bottom left. So you're just going to take this 2, right? 2, the first is just 2, and distribute it to both terms. So that becomes 2 times x is 2x, and 2 times 9 is 18. So we'll have 2x plus 18. Okay, so bring down the equal sign, and we'll have 2x plus 18. Okay, I mean, since we have a x squared in our equation, it's already positive, I'm going to take everything from the right-hand side of the equation and bring it over, right? We want one side of the equation set equal to 0, so we can solve. So I'll subtract the 2x and subtract the 18. All right, so everything on the right cancels. On the left, we have x squared. And then if you combine the negative 5x and the negative 2x, that gives us negative 7x. And bring down the minus 18. And then just factor and make a t-chart and solve. Okay, so two numbers that multiply, where am I here? Multiply to negative 18 and add to negative 7 would be negative 9 and positive 2. So we get x equals positive 9 and x equals negative 2. Okay, remember, we don't just cross this off because it's negative. We have to see if when we substitute the numbers back in, if they create negatives anywhere. Okay, so let's start with the positive 9. If I take positive 9 and plug it in, 9 squared minus 5 times 9 is going to give us a positive value. Okay, if I take the 9 and plug it in here, 9 plus 9 is also going to give us a positive value. So we can take this and circle it. That's okay. All right, now let's plug in the negative 2 and see what happens. If we take negative 2 and substitute it in, I'm going to actually do this off to the side just so you could see it. Okay, so we're going to have negative 2 squared minus 5 times negative 2. Okay, all I did was I took the negative 2 and substituted in for the x. So negative 2 squared minus 5 times negative 2. All right, so negative 2 squared, negative 2 times negative 2 is positive 4. And then negative 5 times negative 2 is positive 10. So that actually gives us positive 14. So even though this is a negative number, when you substitute it back in, it gives us a positive value. Okay, now let's see what happens when I take it and plug it in here. Negative 2 plus 9 is also positive, right? That's positive 7. So even though this is a negative number, when you plug it back in, it creates positive log, so we can use it. All right, so the last one we're going to take a look at is number 7 for today. So again, we see with this one we have subtraction, so we know we're going to combine these into one single log term using the quotient rule, using division. So I'm going to rewrite this as log base 3 of x squared plus 2x divided by x plus 4, and then bring down the equals 1. Okay, so whatever's before the subtraction sign goes in the numerator, whatever after the subtraction sign goes in the denominator. All right, so same thing we've been doing. I'm just going to kind of quickly go through it. Circle the base, run the race. So the 3 becomes the base on the right-hand side of the fraction equation, and the exponent is 1. And I'm going to bring down the x squared plus 2x over x plus 4. Okay, so let's just take this 3 and put it over 1, and let's cross-multiply again. All right, so when I do the top left times the bottom right, I wind up getting x squared plus 2x, and then I'll bring down my equal sign. When I do the top right times the bottom left, I'm going to distribute this 3 to both terms. So 3 times x is 3x, and 3 times 4 is 12. All right, so that's 3x plus 12. Okay, so now we're just going to set, I'm just going to set the right-hand side of the equation equal to 0 by subtracting the 3x and subtracting the 12. Okay, so that all cancels on the right, so we get 0. And on the left, we have x squared, and when you combine the positive 2x and negative 3x, that gives you negative 1x, so negative x, and then bring down the minus 12. And same thing we've been doing, just factor, t-chart, solve. All right, so two numbers. Well, first, I'm going to put an x and an x, and then we're going to come up with two numbers that multiply to negative 12 and add to negative 1, so that would be negative 4 and positive 3. Okay, so we get x equals 4 and x equals negative 3. And let's just see if when we substitute these back in, if it creates a negative log anywhere. All right, so let's start with the 4. So if we take the 4 and substitute it in, 4 squared plus 2 times 4, well, that's going to give us a positive number, right? 4 squared is 16, and then 2 times 4 is 8, so 16 plus 8 is positive 24. All right, then if we plug in the 4 here, 4 plus 4 is, again, positive 8. So that one we can keep. All right, now let's try it with a negative 3. So if we do negative 3 squared, well, negative 3 squared is positive 9, and then 2 times negative 3 is negative 6, so 9 minus 6 is positive 3. So when we substitute this in, this creates a positive. All right, if we take negative 3 and plug it in here, negative 3 plus 4 is positive 1. So we can use the negative 3 as well.